Today the work item feature becomes personal. An anonymous caller receives an authorized. A registered user can log in, create a work item, and list only work that belongs to that authenticated identity. A second user cannot see the first user's item. We will use ASP.NET Core Identities API endpoints so password hashing, credential verification, lockout hooks, and token issuance do not become homemade security code. The important lesson is that authentication is not a login form. It is an identity store, a session mechanism, authorization at the root, resource scope in every query, and tests that prove the boundaries. Separate for questions. Identity answers who the account represents and how credentials are verified. The session answers how later requests prove that login without sending a password again. This could be a secure cookie or a bearer token. Authorization answers whether the authenticated principal may use a capability. Resource scope answers which specific records the principal may access. A root can require authentication and still leak data if its query forgets the owner filter. Keeping these questions separate makes security reviews clearer and prevents one successful login from being treated as permission to read the whole database. The application user is deliberately small and extends identity user. The DB context now derives from identity DB context and calls the base model configuration before mapping work items. Identity owns password hashes, normalized user names, security stamps, tokens, claims, roles, logins, and lockout state. The feature model does not know how passwords work. That separation is both safer and easier to evolve. The new migration adds the identity schema plus one owner ID column and index for work items. Read that migration as carefully as the first one, especially when adding a required owner to an existing production table that already contains data. Register authorization and identity API endpoints, then connect the identity stores to our EF Core DB context. Authentication middleware reads the session and constructs the claims principal. Authorization middleware evaluates endpoint requirements. Mapping identity /account gives us registration, login, refresh, and account management contracts supplied by the framework. This is a teaching baseline, not a complete public account journey. A real product still needs confirmed email, recovery, multi-factor authentication, rate limiting, monitoring, privacy controls, and carefully configured cookie or token transport. Start from the framework security primitives rather than inventing password storage. Require authorization on the work item root group rather than remembering it on every individual endpoint. Both create and list now reject anonymous requests before the handlers execute. Group-level protection also makes the contract obvious during review. Later, specific endpoints can add policies for capabilities such as completing or administering work. Do not confuse require authorization with resource isolation. It proves that some authenticated principal exists and meets the current policy. The next step must still derive the exact owner from that principal and include it in persistence. The endpoint receives the claims principal created by authentication and reads the standard name identifier claim. The request still contains only the title. The owner is passed into the model from trusted server context. If we allowed an owner ID property in JSON, any authenticated user could attempt to create work for another account. Treat a missing name identifier as a server configuration failure, not as anonymous input. In larger systems, wrap this claim parsing behind a small current user service so every feature uses the same required identifiers and assurance rules. The principal stays the same, scope is resolved on the server. The list query receives the required owner identifier and applies the predicate before materializing any rows. Do not load all work items and filter them in memory. That wastes data access and creates a dangerous window where another layer can accidentally observe records it should never hold. The relational model adds a composite index over owner and creation time because that matches the exact filtered ordering query. Root authorization and query scope are both required. A future detail, update, or delete endpoint must make the same ownership decision before returning the resource. The integration test does not install a fake authenticated principal. It registers a unique account through the mapped identity endpoint, logs in with the password, reads the returned access token, and attaches a bearer header to later requests. That proves our identity registration, credential verification, token handling, authentication middleware, and protected endpoints cooperate. For tests focused only on authorization rules, a controlled fake handler can be faster. For this pilot, the real flow is valuable because the lesson claims that registration and login work. Tests should execute the behavior the lesson promises. A positive login test is not enough. The anonymous test creates a normal client with no session and sends a valid-looking work item request. The expected result is unauthorized. This proves the root group is protected independently of title validation. In a deeper test, we could also confirm that no row was inserted. Negative tests are especially important around security boundaries because the failure behavior is the feature. Be precise about status codes. Unauthenticated usually maps to 401, while an authenticated principal that lacks a required permission usually maps to 403. The most important pilot test creates two independent identity accounts. Alice creates a private work item. Bob calls the same list root with his own valid token. His response must not contain Alice's title. This is the first resource isolation test, and it would catch a missing owner predicate even though both users are correctly authenticated. As the application grows, prefer assertions against stable identifiers rather than titles, and verify detail, update, and delete commands too. For multi-tenancy later, the scope will combine user and tenant context, but the habit begins here. Prove isolation with at least two principals. The built-in endpoints remove dangerous reinvention, but production authentication still needs product decisions. Confirm email before trusting an address. Provide recovery without revealing whether an account exists. Use multi-factor or fresh step-up authentication for sensitive changes. Browser applications often prefer secure, HTTP-only, same-site cookies so JavaScript cannot read the session token. Mobile clients need protected token storage and refresh handling. Add rate limits, lockout monitoring, security event audit, revocation, and data protection key management. Never log passwords, raw reset tokens, or bearer tokens. The framework supplies primitives, your threat model and operations complete the system. We added identities, account store, and endpoints, carried the session with a bearer token, required authentication for the feature group, derived the owner from the server principal, filtered every list query by that owner, and proved both anonymous rejection and cross-user isolation. 5 integration tests now pass on the final pilot checkpoint. In the next lesson, authorization policies will move beyond any logged-in user and express a RAIL capability. Later Blazor and mobile lessons will choose session transport appropriate to each client. Remember the compact rule: authentication establishes identity, authorization and server-side scope protect the action and the data.